Hello friends, now we'll discuss regarding the fits. Now fit is nothing but the association between the mating parts. It is the relationship between the two mating parts. The external features are called as the shaft and the internal features are called as the hole. Whatever the relationship will be developed between the shaft and hole, it is called as the fits. Now these relative motions, it may be a tight, loose fitting, it may be a sliding fit, it depends on the type of clearances are available. Now these fits are being classified into the three broader category, that is the clearance fit, transition fit and interference fit. Now let us see each and every fit in details. Now clearance fit. Now as shown in figure, okay, there are two terminologies are there, minimum clearance and maximum clearance. The minimum clearance is the difference between the minimum size of, now I will explain what is this. This is a hole, capital letter shows it is a hole. Now it shows it is a hole based system because minimum size of hole is equal to the basic size or zero size. This is the minimum size of hole, maximum size of hole. This is the maximum size of shaft, this is the minimum size of shaft. Holes are represented by the capital letters and shaft are represented by the lower cases. Now there are two terminologies are there, maximum clearance and minimum clearance. It is the minimum clearance is the difference between the minimum size of hole and maximum size of shaft, and maximum clearance is equal to the difference between maximum size of hole minus minimum size of shaft. Now this is the tolerance for the hole and this is the tolerance for the shaft. If you observe here from C11 to H6 and H11 to H7 is there. Now if you observe the differences, a gap is available between hole and shaft, that's why it is a clearance fit. Now in case of a transition fit, okay, it is intermediate between the clearance fit and interference fit. Now in case of interference fit, okay, now the hole sizes will vary. The hole sizes will shaft sizes are going to vary. This is the minimum size of shaft, maximum size of shaft, maximum size of hole and minimum size of hole. Now the minimum size of shaft is greater than the maximum size of hole, therefore definitely that will be the interference will be available. And the fit which is not going to lie between clearance and interference, that will be called as a transition fit. Okay, now let us see each and every fit in details. Now first of all we'll see the clearance fit. Now the in clearance fit there will be the gap will be available between shaft and hole. There are two basic terminologies are there for that, minimum clearance and maximum clearance. Minimum clearance, it is the difference between minimum size of hole and maximum size of shaft. Okay, that is called as a minimum clearance, and maximum clearance is equal to the maximum size of hole and minimum size of shaft is called as a maximum clearance. Now further the clearance fit will be classified into three subcategory, that is a sliding fit, running fit and closed running fit. Now let us see. This is the shaft and holes dimensions are there. This is the maximum size of shaft and this is the minimum size of shaft. This is the minimum size of hole and maximum size of hole. The minimum size of hole is greater than the maximum size of shaft, therefore shaft will easily move between the hole, therefore definitely it is a clearance fit. Now let us have one example. Suppose a hole is having a value that is 20 plus 0.1 and minus 0 is there, and shaft is having a dimension that is 20 minus 0.1 minus 0.2 is there. Okay, therefore the whole dimensions will be, maximum diameter of hole will be equal to the 20 plus 0.1, that is 20.1 maximum dimensions of hole, and minimum diameter of hole is equal to 20 minus 0, that is equal to 20. The shaft dimensions are there, that is 20 maximum shaft diameter will be equal to the 20 minus 0.1, that is 19.90, and minimum shaft diameter will be equal to 20 minus 0.2, that is 19.8 is there. Now we need to calculate a minimum clearance and maximum clearance. Now minimum clearance will be equal to the minimum size of hole minus maximum size of shaft is there. Okay, therefore you will get equal to the 0.1, and maximum clearance is equal to the maximum size of hole minus minimum size of shaft, that value is 0.3. Now as both the values are positive, therefore it is definitely called as a clearance fit. Now there are some standard types of fits are available here. Now next terminology is there, that is your interference fit. Now if the difference between the hole and shaft sizes are negative, then that type of fit is called as the interference fit. Again there are two terminologies are there, minimum interference and maximum interference is there. Now the magnitude of the difference between maximum size of hole and minimum size of shaft in an interference fit is called as the minimum interference, and the maximum interference will be evaluated as the magnitude of the difference between minimum size of hole and maximum size of shaft is called as the maximum interference. Now these fits are further classified into the push fit, press fit, dry fit and heavily dry fit is there. Now if you have seen, that is, this is the maximum size of hole, minimum size of hole, minimum size of shaft and maximum size of shaft is there. Now minimum size of shaft is greater than the maximum size of hole, therefore it is definitely the interference fit. Now take one example. Now minimum different dimensions of the holes and shafts are being shown here. That is, the minimum size of hole is equal to 20, maximum size of hole is 20.1, minimum size of shaft is equal to 20.15 and maximum size of shaft is 20.2. Therefore, the calculate minimum interference and maximum interference, both the value will indicate it is the interference fit. Now these are some of the standard types of interference fits are being shown. Now the next fit is that is the transition fit. The fit which is not going to fall between the clearance and interference fit, then that type of fit will be declared as a transition fit. Now generally the transition fits are being used in the machine tool gearboxes, anti-friction bearings. These are going to use the transition fit. Now how to evaluate it? It will be intermediate between the clearance and interference. Now this is a hole based system, hole dimensions are fixed and shaft dimensions will vary. Now here it is a minimum diameter of shaft and maximum diameter of shaft. This is a minimum diameter of hole and maximum diameter of hole. Therefore one of the clearance will be negative here. Now in case of transition fit, one of the clearance will be negative, then that type of fit will be called as a transition fit. This is some standard designations of the transition fits are there. Now there are two types of fit systems are available, that is shaft based system and hole based system is available. Now let us have one pictorial view for that, hole based system and shaft based system. In case of hole based system, the hole dimensions are being kept as a constant. Minimum diameter of hole will be equal to the basic size and the shaft dimensions will vary. In case of shaft based system, shaft dimensions will be kept constant and hole dimensions will be varying. Now to change the diameter of shaft is easier compared to the change the diameter of hole, because holes are being created by using a standard drill bits are there and the diameter of drill bits are fixed. Therefore to change or vary the dimension of hole, it is difficult compared to the shaft dimensions. Therefore generally the hole based systems are being used. Now let us see here, it will show the hole based system and shaft based system. Here shaft dimensions will vary, hole dimensions are fixed. Here hole dimensions will vary and shaft dimensions will change. Now let us have one example for that. Now if we are having a system is there, that is the 45 E8 E7 is there. Now this pictorial view will show that different clearances and tolerances will be shown to us. Now ES will show the upper deviation and EI will show the lower deviation to us. Now capital letter shows for the hole and small letter will show the for shafts. Now 8 is nothing but 8 and 7, it is nothing but it is the fundamental tolerance grades are there. Now there are 18 fundamental tolerance grades are there, that is IT 1 to IT16, IT01 and IT0 is there. These totally 16 plus 2, there will be the 18 grades are there. Now what is the corresponding tolerance value is available for IT8 and IT7 grade is there, that will be decided as per the standard charts are there. Now how to decide that value by using a standard chart? Now this will show, now E8 and E7 is there. Now this is capital letter is for hole and small designations are for the shaft. Now it will show the tolerance values are here. Let us see here. Now this tolerance value, now let us see, this is a 45 E8 and E7 is there. Now 45 diameter is going to lie between a range is there, that is 30 to 50. Now we want to select E8. Now see the corresponding value, it is 39 microns, means it is a 0.039 mm, and E7 is nothing but 25 micron, that is a 0.025 microns is there. Now it will show the unilateral tolerance. Now you will have both the charts are there for unilateral and for bilateral is also there. Now suppose I want to go for a 45 E8, that is 30 to 50 is there. Now E8, that is the two dimensions are shown, minus 50 and minus 89 is there. That is minus 0.05 and minus 0.089 is there. Now some different charts are being shown here. Now what are the charts are required? We can select as per our requirements, that is the tolerance zones that will be shown, that is the E8, that is, and small E8, then this will be shown. These are the tolerance dimensions are being shown. It will show the upper deviation and lower deviations. Now let us have one example of 30H7P6. H7 is the tolerance for hole and P6 is the tolerance for the shaft is there. Now how to evaluate for the hole and shaft? Let us see. Now the IT grade for the H7 hole dimension is equal to the 21 microns. It is the upper deviation. Now what is this H7? Where is the H is there? H is available in the chart. Here is the H available. Now let us see what is this tolerance, 0.021 or 21 micron, that is, this is the tolerance zone is there. Then next one is a grade 6, that is the P6 is there, having a tolerance microns is a 13 microns. For the 13 microns, this is the tolerance zone is there, and 22 microns is the upper deviation is there. Now let us see, accordingly using this tolerance we can evaluate the upper limit and lower limit for shaft and holes. Now you will get the different dimensions of shaft and hole. If you observe here, maximum diameter of hole is less than the minimum diameter of shaft, therefore definitely it is the interference fit. Now I think everybody is clear for the types of fit. Now I'll give you one simple thumb rule for that. We will calculate the maximum allowances and minimum allowances. Maximum allowance is equal to the maximum limit of hole minus minimum limit of shaft, and minimum allowance is equal to the minimum limit of hole minus maximum limit of shaft. If both the allowances are positive, then that fit will be clearance fit. If maximum allowance is positive and minimum allowance is negative, then that will be the transition fit, and if both the allowances are negative, then that type of fit is equal to the interference fit. Now let us have one more example to determine the type of fit. The example says that find out the limit of hole and shaft for the clearance fit on the hole based system for the basic size of 30 mm diameter with the minimum clearance of 0.2 mm, tolerance on the shaft is 0.075 mm and tolerance on the shaft is 0.05 mm. Now using this tolerances value with the basic size of 30 mm, we can evaluate the different dimensions of the holes and different dimensions of shafts as well. From this we will get different limits of shaft, it is 29.725 and maximum is 29.8, and hole dimension maximum limit of hole is 30.05 and minimum limit of hole is 30. Now minimum limit of hole is 30 and maximum limit of shaft is 29.8. Gap is available, therefore definitely it is the clearance fit. For that we can evaluate the maximum allowance as well as the minimum allowance. Both the allowances are positive, therefore it is a clearance fit. Thank you.